Hello everyone, I'm Paul and today we're solving problem 2131, longest palindrome by concatenating two-letter words. This is a medium palindrome problem and here I will show you how to solve this efficiently, so keep watching. We're given an array of strings words and each word has only two lowercase letters. And our job is to create the longest possible palindrome by selecting some elements from words and concatenating them in any order. We can select each word at most once and we need to return the length of the longest palindrome that we can create. Now, in case you don't know, a palindrome is a string that reads the same forward and backward. So for example, A, B, A is a palindrome. Now let's say we have these words and from these we can form L, C, G, G, C, L, and this is a palindrome. You can read this the same forward and backward. This is the middle. So here we have 1, 2, 3, 4, 5, 6 characters, so the result is 6. Now let's see how can we solve this. Let's say we have these words, we also have a map, and the result is initially 0. We will iterate this from left to right, starting from index 0. So first the I pointer is here. And every time we will take the current word and we will reverse this. So in this case we will get CL. And we will check if we have this in our map. If we don't have this in our map, we will add the original word to the map. So in this case, we add to the map a key with LC and a count of 1. Next, we update the I pointer and we are checking if we have LC in our map. And we do, it's here. So in this case, we can remove this from the map. So this is now 0 and we can add 4 to the result. Why? Well, let's say we are building this string, we will call this S. And up to this moment, we have, for example, this CL and LC. Okay, this is already a palindrome. So we can already add these 1, 2, 3, 4 characters to the result. And now we have already used these two words, so we don't care about them anymore, and the map is empty again. Next, the I pointer is here, and we are checking if A is in the map, and it isn't. So we add that as a key with a count of 1. And next we update I again. Next, we are checking if we have AA in the map again, and we have that here, so this is now 0, and we can add 4 to the result, so this is now 8, and our current string would be AA, CL, LC, AA, okay, and this is a palindrome, so we are good to go. Remember, now the map is empty, we won't use this and this in the future. So next we update I. Next we are checking if we have a positive count for AA in the map, and we don't, this is 0. So now this is 1 and we update I again. Next we are checking if we have WX in the map, and we don't, so we add XW with a count of 1. Next we update I, we reach the end. And this is our final map. Now, up to this moment, we can build this string, for example. And if you look carefully, here in the middle, we could add one more string only if both characters in the string are equal. Now remember, every string has only 2 characters. And if we look our map here, we have one string available with 2 equal characters. So we could add a here in the middle and we could add 2 more to our result, so this would be 10. So the final result in this case will be 10. Space and time complexity for this approach will be big O of n, because we are iterating the array with words and we are building this map. So now let's go with the code and hopefully you will get the idea. First, map is default dictionary, and we will set a default value of 0 for every key like this. Now result is initially 0, and for every word in words, the reversed word will be word at 1 plus word at 0. And if we have this reverse word in the map with a count greater than 0, so if map at reversed, we add 4 to the result and we subtract 1 from map at revert, else map at the current word plus equal 1. And finally, for every key in the map, as soon as we find a key with equal characters and a positive count, we add 2 to a result and we break the loop. So if k0 equals k1 and map at k is positive, result plus equal 2, break, and finally we return the result. This is it for the code. Remember that you can store frequencies in a hash map or in a nested array. In this case we are using Python default dictionary. So now let's submit this and see if it works. As you can see, this works and it's efficient. So if you found this useful, please drop a like, subscribe, and see you in the next one. Bye bye.